Hey there, I'm Vaishnav and I'm here to talk about the chat application schema which supports all types of communication, be it one on one, groups, or channels. Not only that, we'll dive deeper into online offline indicator and how to handle sending messages. Without further ado, let's get started. So, here is the breakdown of the database schema for the chat application. We have the users table for storing users info and the chats table for storing the chat's metadata and the memberships table for linking the users to the chats and the messages table for recording chat messages. So to establish one-on-one communication between two users, say 2 and 3, for that we need to create a new chat. Let's say we created it and it returned 1. Now with the returned ID, we need to create 2 memberships. After creating a membership, we can use it to send messages. Now let's focus on how to render the chats onto the front end. Consider a user with ID as 1 and let's say he is present in 2 chats with ID 5 and 6. So for rendering it onto the front end, we need to query it like select everything from the memberships where user ID equal to 1. That's it. You can get all the chats where the user is present in. Before diving into the online or offline indicator system, let's first understand what a WebSocket is. WebSocket is a protocol that upgrades a standard HTTP connection into the full duplex real-time communication channel over a single long-lived TCP connection. What does it mean by full duplex? Full duplex means the client can send the data to the server and client can also receive the data from the server. So as we understood what WebSockets are, now let me just dive into online or offline indicator system. As you can see that the client is interacting with two components, one being the HTTP server and the other is the WebSocket server. When the client logs in, we need to update the last scene of the client at the moment, which will offer good user experience. Now after logging in, the client establishes a long-lived TCP connection with the WebSocket server, which is bi-duplex in nature, which will send the heartbeat to the server. Once the heartbeat is received, we can typically use a map or a cache with TTL, which is set to leave after some seconds, and update the results over there. Now after 30 seconds or some seconds, we can process them in batch, which will give us a performance boost. Now let's explore how message sending would work in 3 different types of applications like Telegram, Zoom, and some business application with the primary focus on persistence and reliability. In Telegram, messages are sent in real time and stored for future reference. When user 1 sends a message to user 2, it's first added to the message queue and delivered via WebSocket. Consumers would process the message from the message queue and save it to the database for the persistence. In contrast, Zoom primarily focuses on the real-time communication with no persistence at all. Messages are broadcasted directly through the WebSocket. Now, for a business application which prioritizes persistence and reliability, messages are sent using the HTTP server, and the message is basically processed into the database and then it's delivered to the user 2 via WebSocket. This ensures that the message is persisted